My name is Gary Willett, and I'm the sole owner and proprietor of Icarus Engineering and Solar Services Limited Liability Corporation out of Irving, Texas. I had the privilege of working with Cohen Enright of Intech Electronics on the upgrade of the PV system here at the JT Ranch. And we're finished, and now we're wrapping it up today. I did some labeling, and now I'm going to do a little overview of the system. We'll understand how the system is designed, and most of all, what the indicators are that everything is working well, or there might be something amiss. So first, I'm going to give a little overview of the major components of the system, and then I'll go into just a little more detail of how the entire system components interact with each other to produce electricity. On the roof of the barn, there are 8 solar panels that come down through the roof through this conduit into this particular enclosure here. This is the PV source circuit disconnect. This allows you to individually turn on or off the PV source circuits individually. The way the PV modules are wired, 2 modules are wired in series, and those 2 modules, say PV module 1 and 2, become PV source circuit number 1. PV module 3 and 4 are 2, 5 and 6 become 3, and 7 and 8 become 4. And these breakers are normally in this up position, and when they're off, they're down. So you always want to make sure that these are up, unless you're doing some kind of maintenance on the system. These 4 units here were from the existing system. These are charge controllers, and I'll get into a little more detail about them in a minute. This little enclosure here is just a convenient way to wire and interconnect all the wiring together in and out of the PV module wiring and the charge controller wiring. This unit here is the maintenance unit for the Magnum Energy inverter system. It allows you to set the inverter settings. It also has some historical data for how much the inverter is producing as far as power. This unit here is the inverter. This is a 4,000 watt inverter. This unit was already here, and we reused it. When we upgraded the system, we added this particular box here, and this unit allows us to put in all the circuit breakers and the means to turn on or off the different components without having to disconnect wires and whatnot. And I'll get into a little more detail on this one in a minute. These units right here are surge protection devices, SPDs, and what they do is protect the electronics in the inverter from surges that might come in from through the solar panels due to maybe a lightning strike nearby coming in through the solar panels. This is an AC surge protection device that protects the inverter from surges that might come in from the power line equipment. And over here, of course, we got the schematics of the system that shows how the system is interconnected and wired. This panel right here used to be the only panel that was in here, but so we repurposed it when we redid the system to be the panel that the AC loads that are powered by the inverter, they're all served out of this panel. We call it a protected loads panel, PLP, and these are the loads that are powered by the solar PV system. And then this was the new panel that came in, was installed when the AC service was installed. This has from the utility service disconnect breaker to disconnect the grid power. These are some loads that are served out of this particular panel that are not backed up by the solar equipment. And this breaker down here in the lower right is the breaker that feeds the grid power into the solar PV equipment. And normally, of course, this breaker would be on and feeding power. This quad outlet box here is powered off of one of the breakers in the inside of this panel, in case you wanted to run just some convenience loads. I think we put, this is what, a 25 or 50 amp circuit here that we put in for plugging in maybe an RV or something like that.
Yeah.
And those are all powered off of this panel and are not protected by the inverter. And then down here, last but not least, is the battery bank. This particular battery bank is 24 volts DC. We've got 4 6-volt batteries that are put in series together to make 24 volts DC. These batteries have about a 400 ampere hour capacity, and for the most of the part, these batteries are what they call floating, in that they're used during the daytime. The nighttime to power the loads from this panel, but during the daytime there's enough solar power coming in that the batteries stay charged, and there's enough power for the inverter to power the local loads. So then at nighttime, when the sun goes down, all of the loads that are served from this panel are powered from the batteries, and the inverter is smart enough to know, and it's programmed to when the state of charge of the battery bank gets down to about 80%, which is 80% of full, and if the grid is connected, it will then start taking power through this grid feed connection and using that power to keep the batteries charged. So we don't want the batteries to drop down below 80% if we can avoid it. That allows for the best longevity of the batteries if you don't discharge them more than about 20%. This panel here is how the AC grid circuits come in. This also has a large circuit breaker here. This circuit breaker here is for the battery bank. It's a 250 amp DC breaker, and the 24 volts coming up from the battery bank, the positive terminal goes through this breaker first before it goes into the inverter. So that allows you to disconnect the power into the inverter if you want to. These breakers right here, these are for the the charge controllers, the tracer charge controllers. You got charge controller 1, 2, 3, and 4, and each one of these, you've got the PV coming in. Like here is PV source circuit number 1 coming in from here, which is this breaker right here, and then the output from this charge controller, which the output of the charge controller is what actually charges the battery. So charge controller number 1 comes into this breaker right here, and you can turn it off or on if you're wanting to work on the charge controller or whatever. It allows you to individually control them. The output of all these 4 charge controllers then go through this particular breaker here. Okay, this particular breaker here is the ground fault detector and interrupter, which is required by the National Electrical Code to prevent someone from getting shocked by the solar panels. And so if this circuit breaker detects a fault between the battery negative and the ground coming down from the solar panels, if it sees power flowing in that connection, there should not ever be, but if there is, that means there's a ground fault. And what happens is that this little 1/2 amp breaker here trips, and when it trips, it causes a bigger breaker inside here to trip, which essentially makes effectively all of these breakers then are disconnected from the battery bank. Okay, with this one breaker. So in order to reset it, you have to, if you saw this, it would be down. That would tell you that a ground fault was detected. If you went and you tried to restore that and it wouldn't stay set, that means there's a ground fault that needs to be repaired before you can bring your PV modules back online. So hopefully that won't happen, but if it ever does, this essentially takes all of the PV modules offline if it's tripped. This particular circuit breaker here is another circuit breaker. Over here in this panel, the main service panel, there was a 30 amp breaker right here. This is what feeds the inverter. It comes out this cable here and into here. Well, first it goes into this breaker right here. Okay, so it gives you another place to disconnect it. You can turn it off there, or you can turn it off there. So under normal operating condition, this breaker would be up or on. And if it's tripped, that means that something somehow the inverter had more current flowing than it could handle. This set of breakers right here is pretty important. These breakers do is they allow you to totally bypass the solar equipment. If you're going to do maintenance on the batteries or on the inverter, and you don't want the loads that you're powering through this panel to be affected, what you do is you go in and you flip these up like this. And what that does, when I throw it like that, and I throw this one up and that one down, what happens is the power that's coming in on this cable from the panel goes up into these breakers and right back out again to this panel. So you've effectively bypassed all of this equipment. And sometimes there may be a reason why you want to do that. Maybe you're going to do a firmware update on the inverter. There could be a problem with the batteries that you might need to do some maintenance or whatnot. So being able to do that, it gives you a fail-safe way to, if your power is not working off of the solar, you can go in here and isolate the solar equipment and have everything working off the grid. So right now we're in the bypass mode, and if you see here, it says switch is on to bypass inverter. So you see this switch is on or up. Okay, this one is down, which is normal operation. It's up. Okay, so you do have the ability to switch both off. That will take the AC output off of this as well. But normally, when you're just wanting to do bypass, you would just flip these breakers like so. And now we're back into inverter operation. The loads are running off of the solar, the PV, and the batteries. Units here, we talked about the charge controllers a little earlier. These manage, each of these handles 2 of the solar PV modules on the roof. This one handles 1 and 2, this one 3 and 4, this one, you drop below that 80% number. The 80% number is when the inverter says I need to go to the grid and get some battery charging. Well, if the grid is down, it'll continue to power the loads, and it'll take the battery voltage from 24, 25 volts nominally that it has down to about 22 volts or so. And then once the battery voltage in the battery bag gets below around 22 volts, the inverter will automatically shut down, because what you don't want to do is totally drain the batteries. That's not a good thing. So to protect the battery bank and also to protect the inverter, it says, okay, when my voltage gets that low, it's time to shut down as a self-preservation mode. But hopefully you shouldn't see that. It would be a rare occurrence, because normally with the amount of loads that you have here, the amount of storage capacity in your batteries, even if you didn't have grid overnight, the amount of discharge of the battery bank should not even get to 80% overnight. If it does, you've got enough solar power when the sun comes up the next day to bring it back up to 100%.